All right, let's dive right into this explainer. If you've been hearing terms like large language models, generative AI, and machine learning tossed around, but honestly, you still feel a bit lost in all the jargon, hey, you are in exactly the right place. We're going to demystify the complex architecture powering today's AI revolution and give you a crystal clear map of how it all connects.
But look, before we get into the weeds, we've got to correct the single most common terminology mistake in tech right now. Seriously, stop confusing AI with machine learning. They're definitely not interchangeable buzzwords. So here's the 30-second breakdown of how this actually works.
Section 1. The Great AI Hierarchy. The Matryoshka Doll.
So I want you to think of the entire AI landscape like a classic Russian nesting doll, okay? The outermost, biggest doll, that's artificial intelligence. It's the whole universe of creating smart applications. Crack that open, and inside sits machine learning, a specific technique that learns from data. Open that one, and you'll find deep learning, which relies on multi-layered networks. And finally, nestled right there at the very center, the smallest doll, that's generative AI. It's a highly specific, incredibly powerful subset that doesn't just analyze data, it actually creates new content.
Now, before we fully unpack the generative part, we have to recognize that deep learning itself is divided up into some highly specialized architectures. You've got artificial neural networks for structured data, convolutional neural networks, which are designed specifically for grid-type data, like images, and recurrent neural networks built for sequences. Basically, these are the foundational building blocks we're working with.
Moving on to Section 2. Discriminative versus generative AI. The paradigm shift. So for years, traditional deep learning algorithms were overwhelmingly what we call discriminative, meaning they were trained on labeled datasets simply to classify, predict, or group existing information. Think of an AI sorting photos into cat or dog buckets. But generative AI, it completely flips the script. Its main job is to generate entirely original data based on the patterns it learned. It doesn't just predict what an image is, it literally paints a brand new image. And guys, the scope of what it can create is just massive. When you ask ChatGPT to write an essay for you, well, that's text-to-text generation. Prompting an AI to create a wild sci-fi painting, that's text-to-image. These models can even handle image-to-image and image-to-text. And just to clarify, large language models, or LLMs, are the specific engines that handle those text-based tasks.
Section 3. The Engine. The Evolution of Neural Networks.
To really grasp how we reach this absolutely unprecedented level of creation, we've got to look under the hood at the engine. Early recurrent neural networks used basic feedback loops to process sequences. Then, decades passed, and the tech evolved into more advanced versions like LSTMs and eventually sequence-to-sequence mapping. But the absolute game changer, the architecture powering pretty much every major LLM today, that arrived in the form of self-attention and transformers.
Which brings us to a frankly legendary phrase in the AI research community. Attention is all you need. This was the actual title of the groundbreaking paper that introduced the transformer architecture. It introduced this concept of self-attention, which allowed a model to look at a whole sentence and understand the context between all the words simultaneously, rather than reading them strictly in order, one by one. Suddenly, AI could understand nuance and intent like never before. I mean, this literally became the bedrock for modern AI.
All right, Section 4, the 3-stage training factory, building a large language model.
So taking that raw transformer engine and building an actual functioning LLM requires a highly specific pipeline. It kicks off with unsupervised pre-training, basically feeding the model massive amounts of raw internet data just so it learns the fundamental structure of human language. Next up comes supervised fine-tuning. And finally, the whole thing goes through reinforcement learning with human feedback, where actual humans rank the responses to make sure the model's behavior is safe and, actually helpful.
Now that second stage, supervised fine-tuning, is really the secret sauce here. See, a model that has only gone through pre-training might just randomly predict the next word without actually answering your prompt. Fine-tuning takes that raw base model and trains it further with high-quality labeled request and response data. This is exactly what bridges the gap between a model that simply knows a language and a model that can perform specific, useful tasks for you. Which brings us to Section 5. Building the AI ecosystem, tools of the trade. Because the models alone, they aren't enough. Developers actually rely on an entire ecosystem to bring these concepts to life. Right at the top, you have foundation models like OpenAI's GPT or Google's Gemini acting as the core intelligence engines.
Then you have vector databases like Pinecone acting as the system's long-term memory. Frameworks like LangChain act as the wiring, and open-source hubs like Hugging Face, they serve as the massive community platform for finding and downloading the whole shebang.
And I want to highlight vector databases because they are essential for one massive reason, preventing the AI from just making things up, which we call hallucinating. These databases store data as embeddings, basically turning a sentence's meaning into a mathematical vector. Think of it like an infinitely organized library. Because these vectors carry deep semantic meaning, the AI can rapidly scan millions of documents and retrieve the exact context it needs before it generates your answer. It's brilliant.
And this is where a framework like LangChain becomes incredibly vital. It acts as the essential glue for the whole system. If you have a powerful LLM on one side and your own private, customized vector database on the other, LangChain is the bridge. It seamlessly connects that core intelligence engine directly to your actual private company data.
Well, we've journeyed all the way from the vast universe of artificial intelligence, straight down to the specific frameworks and databases connecting generative models today. So, now that you truly understand the architecture of this modern ecosystem, the real question is, what are you going to build with it? The tools are out there, and now you've got the map. If you love this structured breakdown, make sure to follow to master the AI era. We're going to keep bringing you clear, concise explainers to empower your learning journey. Keep exploring, and I'll catch you in the next explainer.